Hi students, welcome to Madras Math Kernel. So today what you are going to learn? You are going to learn chapter 2, that is all about polynomials. So here you will be understanding the concepts and also the example explanations related to exercise 2.1. So first you should know what is a polynomial. So here I have given an example for polynomial. So 2y square minus 3y plus 4, it is a polynomial in variable y. So first definition or term you should know here is what is the degree of a polynomial. Degree of the polynomial is nothing but the highest power of the variable in the polynomial. So the example what we have taken here is 2y square minus 3y plus 4, it's a polynomial in variable y. If you observe the degree of y, here it is 1, here it is 2, and here no y, so it is 0. The degree of y is 0 there. So what you can say, the highest degree of y is 2. So 2 is the degree of the polynomial what we have considered here. And then linear polynomial. What do you mean by linear polynomial? Linear polynomial means the polynomial with the degree 1. You can call it as linear polynomial. Already you would have studied about this in your lower classes. So I have given some examples: 2x minus 3, 2 by 3 u plus 1, where the degree of the variables coming there is 1. And then quadratic polynomial. What do you mean by quadratic polynomial? The degree, highest degree of the polynomial should be 2, right? So I have given some examples again: y square minus 2, 4z square plus 1 by 7, where the degree of the variable is observed to be 2 there. And cubic polynomial, as the name says, cube means 3. So here the degree of the polynomial should be 3. So consider some example: p of x is equal to x square minus 3x minus 4. I'm sorry. So this is not the example for cubic polynomial. Here you can say 2x cube plus 3x square minus 5x plus 2 equal to 0. You can take this as an example for cubic polynomial. The degree of the highest degree of the variable taken here is 3, right? The highest degree of the variable, what variable here it comes? X is the variable in the considered polynomial. The highest degree of x is 3. So the degree of this polynomial is 3. Now what do? You consider a polynomial of degree 2. P of x is equal to x square minus 3x minus 4. So here you know how to find out what is P of 1. P of 1 is nothing but replacing all your x with 1. So P of 1 is equal to, substitute wherever you have x, you substitute it for 1. So 1 square minus 3 into 1 minus 4. So on simplification, this will gives you minus 6. Similarly, you can find out what is P of k. P of k is k square minus 3k minus 4. Wherever x, you have to replace your x with k. Similarly, you can find out P of minus 1 also. So if you find out P of minus 1, it is giving you 0. So what you observe from here? When I substituted x as 1, I got minus 6. When I substituted x as k, I got this equation, or I got these terms. And when I substituted x as minus 1, then I got 0. Again, I am substituting p of, I am finding out p of 4. I am substituting 4 for x. So I am getting 0. So here what you can observe from this, when we substituted x as minus 1 and 4, we got p of minus 1 as 0 and also p of 4 as 0. So we can say, whenever if you get 0 after substituting the x value, then you can call that particular value, particular x value as zeros of the given polynomial. Here, since you got the polynomial value as 0 after substituting your minus 1 and 4 for x, then you can call this minus 1 and 4 as the zeros of the given polynomial. Okay. So generally speaking, what you can say, k is said to be a 0 of the polynomial p of x only when p of k is equal to 0, right? Coming to the 0 of a linear polynomial. So I am considering p of x is equal to 2x plus 1 as a linear polynomial here. So what I am doing, I am substituting k for x. So wherever x, I am replacing it with k, and then I am equating this expression to 0. So I am getting k is equal to minus 3 by 2. So with this, what I could able to understand. So whenever my x becomes minus 3 by 2, the entire polynomial value becomes 0. Then you can say this minus 3 by 2 as the 0 of the given linear polynomial, right? So in general form, what you can say, in the form of a formula, if you want to put it, then you can say in generalized form, I have taken the polynomial as ax plus b, where a and b are integers, and I could observe k is equal to minus b by a. So what is this b? This is nothing but the constant term in the given equation. And what is this a? This is nothing but the coefficient of x in the given polynomial. So again we will be trying to explore the zeros of other polynomials like quadratic polynomial, cubic polynomials also in the forthcoming sections. Then coming to the geometrical meaning of the zeros of a polynomial. Geometrical meaning means what is the impact of the 0 when it is represented as a graph. Okay, so example 1, just considering this is not the book example, this is example something what I have taken to explain this idea. So given the linear polynomial, for example, y is given as 2x plus 3. This is a polynomial what I have considered to explain this graph. It is passing through 2 points, minus 2 comma 1 and 2 comma 7. So with the help of these points, I have drawn the actual graph. One is minus 2 comma 7. So I have plotted x is minus 2. I'm sorry, one point is minus 2 comma minus 1. So x is minus 2 and your y is somewhere here. So minus 1. So I have marked this point, and another point is 2 comma 7. Your x is 2 and your y is 7. So I have marked this point. So after marking, I joined those two points and I got a straight line over there, right? So in order to make our work easy, I have given this x and y variables, y values in a table. Okay, so I have drawn a graph like this. So if you observe the graph, then you can understand the graph cuts the x-axis at only one point. So what is the value of that point? If you observe in the graph, it is the midway between minus 1 and minus 2. So it should be minus 1.5, right? It should be minus 1.5. Therefore, the point at which your graph cuts the x-axis is minus 1.5 comma 0. Also, in the previous section, we had a formula for finding out the 0 of the given linear polynomial. That is, what is the formula for that? Considering this as ax and this as b, the formula for finding out the 0 is minus b by a, right? Where b is a constant term and a is your coefficient of x. If you apply the similar methodology or formula here, b is your 3 and a is your 2, right? So your formula is minus b by a. So minus, I have put it here, and instead of b I have written 3, instead of a I have written 2. So minus 3 by 2. So this is what the 0 I got by using the formula. Okay, so if you compare these two, then you will observe both are same. The point at which your graph cuts the x-axis and the 0 what you got from the formula, both are observed to be same, right? And from the graph you can observe wherever it cuts the x-axis, then that point is going to be the zeros of the given polynomial, that you can conclude. Then also one more conclusion you will arrive, that is number of zeros and number of points at which the graph of the given polynomial intersects the x-axis, both are observed to be equal. That is, since here it's a linear polynomial, you will be getting only one zero and only one point where the graph cuts the x-axis. But if it is in the case of a quadratic or cubic polynomial, then the number of zeros and number of points at which the graph cuts the x-axis will vary. Okay, so whatever may be the conditions, you will be arriving with this scenario always. Your number of zero and number of points where the given graph cuts the x-axis is going to be same. Then coming to another example I have considered for explaining the concept of zeros. I have taken y is equal to x square minus 3x minus 4. So I have taken some random values, some minus x is equal to minus 2 to x is equal to 5 I have considered, and I have substituted in this considered polynomial. Then I got the y values as 6, 0, minus 4, minus 6, etc. So what I have done here is I have marked all those points as a graph. So after marking all those points, I am getting a graph like this, right? So from this, what you can conclude, the shape of any quadratic equation or any quadratic polynomial, it will be always like a open U. Sometimes it will be upside down, inverted U's also you can, normal U or an inverted U also you can observe. And these shape of curves, they belong to the family called parabolas. Okay, so from the table, that is from the x and y values, right? Here you can observe where your y becomes 0 when your x is minus 1, and when your x is 4, your y value becomes 0. So if you check the same with the, just a minute. So if you check the same with the graph, then you can observe the same points will be the point where your graph cuts the x-axis, that is minus 1 and 4. Okay, so minus 1 and 4 are the zeros to be observed from the table. A similar pattern you can observe from the graph also. In the graph also you can see x is equal to minus 1 and x is equal to 4 are the zeros, right? Then coming to the next examples, you have three cases here. So what your case one is where your the curve cuts the x-axis at only at 2 points. For example, here this curve is cutting the x-axis at these 2 points. Similarly, if you see this curve, it cuts the x-axis at these 2 points, right? Coming to case 2, you can see the parabola, it cuts or touches the x-axis at only 1 point. Here also it touches the x-axis at only 1 point. And coming to the case 3, you can see it never touches the x-axis. Therefore, here also it never touches the x-axis. Therefore, no zeros. So, from case 1 condition, case 1 graphs, what you can observe, they have 2 zeros and both are distinct. And from case 2 examples, you can observe you have only 1 0, 2 equal zeros are there. Okay, because the polynomial being a quadratic polynomial, you know, for very sure you will have 2 zeros. Since it is cutting the x-axis at only 1 point, then you can come to the conclusion both the zeros are equal. Okay, so then coming to case 3, it does not intersects or touches the x-axis, therefore you don't have any zero over there. Okay, and coming to the third example, again this also I have only considered, that is a cubic polynomial. So y is equal to x cube minus 4x. Okay, y is equal to x cube minus 4x. So here I have substituted again x values from minus 2 to plus 2. I observe these y values on substituting in the given equation. Okay, after calculating the y values, I mark these points as a graph. Minus 2 comma 0, it is nothing but here minus 2 comma 0, minus 1 comma 3. So it is coming somewhere here minus 1 comma 3, and this is 0 comma 0. Similarly, I got this graph. So from the table you can observe you are getting 3 0 values for y. The corresponding x values, if you observe, then -2, 0 and 2 are observed to be the zeros of the given polynomial. From the table you can say it easily. Similarly, if you observe from the graph, it cuts the x-axis at 3 points. So what are those points? One is -2, 0 and another one is +2. Again it is coinciding with the table values, right? And then some two examples I have given again for the sake of understanding. Y is equal to x cube. If you plot this as a graph, the shape of the graph will be somewhat like this. So here you can observe you have only 1 zeros. Since the degree of the polynomial is 3, sure there will be 3 zeros, but all the 3 zeros are equal and it is 0, right? Numerically it is 0. And coming to this example, y is equal to x cube minus x square. So the graph is looking like this. So it is cutting the x-axis at 2 points. One is 1, another one is 0. So it is not 1, it is some value, and here it is 0. So you will be getting 2 zeros, right? So coming to the actual example, look at the graphs given below. Each is the graph of y is equal to px, where p of x is a polynomial. P of x is a polynomial for each graph. Find the number of zeros of p of x, right? So first one, this is the graph given in your textbook. So you can observe it is cutting the x-axis at only 1 point, so we will be having 1 0. Here it is cutting the x-axis at 2 points, so we will be having 2 zeros. So coming to a third example, it is cutting x-axis at 1, 2 and 3. 3 zeros are there. Here it is, you will be having only 1 0. And coming to the other examples, it is touching the x-axis at only 1 point, therefore 1 0. Here it is 1, 2, 3 and 4. So you will be having 4 zeros here. So you should note down this point here, that is, if you are going to find out zeros for a polynomial with n degree, then what you can say, it will cut the x-axis at n points, or it can have at most n zeros. That is, what is the maximum number of zeros it can have is n, because that is the degree of the given polynomial.